Linolenic acid is 18.3. You can find it mostly in soybean oil, canola oil, rapeseed oil, the 22.1. Okay, itulah. Okay, saturated fat, all the chemical bonds between carbon are single bond. Okay, this one you know, no double bond. There is no space for more hydrogen atom, are fully saturated. They are solid at room temperature. So, for example, butter, coconut, fattening, nut, coconut oil. Coconut oil at room temperature, it can be saturated. Palm oil, polyhydrogenated vegetable oil, poultry skin, wholemeal, these are all saturated fat. Okay. For polyunsaturated fat, they have 2 or more double bonds. Okay, include omega-3, omega-6 fatty acids. Okay, linolenic acid are omega-3 fatty acid. Linoleic acid are omega-6 fatty acid. Okay, so these are the richest source of polyunsaturated fatty acid. Includes, so kalau unsaturated, mostly they are from plant origin, plant origin. Okay, so vegetable oil lah, corn, sunflower, cottonseed oil. Okay. So kalau kita pergi US kan, US or North America, normally the type of oil that they actually sell in the supermarket, this type of oil lah, corn oil, sunflower oil, cottonseed oil, cottonseed jarang lah ni, sunflower, corn, soybean oil, because they want to promote the industry, number one. Number two, it is believed that they use this a lot in frying, but actually palm oil is the most stable oil for deep fry, Okay, so they are trying to, because we have a lot of issues of palm oil, they are being embargoed, macam dia sekat lah kita punya the production of palm oil, like Europe is trying to do that, US also is trying to do that, because you know, they mention about how countries like Malaysia, Indonesia are destroying our forests because we want to plant more palm oil, palm trees to produce palm oil. But itulah argument is still going on. Like few years ago pun ada from France, they are trying to sekat the palm oil. But still, if we MPOC, kita ada Malaysian Palm Oil Council, banyak buat, they do a lot of promotion, they do a lot of info sharing about the goodness of palm oil, because we are the producer, right? So they spend a lot of money actually, and they have a lot of activities that involve students, involve the NGOs, and also the general consumers. So please try your best to get involved in this kind of activities lah. You can go to the website of MPOC. Even I think last year they had this very big event in UKM. Not last year, just last semester. Okay, maybe you did not get the message, because they sent it to food science students. So we compete there, and then UPM student, our BSTM student got number 1 lah in terms of product development that use palm resources, palm oil resources, which is actually very good. Okay, so don't believe directly what the media is telling you about the goodness of other vegetables oil than palm oil, because from what we have learned and from the research has been shown a lot actually, that palm oil is the most stable oil that is used, the best oil is used for frying. Okay, alright, ni nomenclature lagi lah, nomenclature macam tadi ya. This nomenclature is C18, this is how it is written, the carboxy N and then the metal N. Okay, So tulislah C punya carbon dia ada 4 kan. For chain supposed to attach to C. So ada 1. If you see here like 1, 2. So the other 2 is by H lah. So yang tak ada, the one that you don't have any C, you have to put the H. Okay. For example, if there is a question asking you how to draw, how to nomenclature this one, so you have to write it this way. Okay. Okay, name according to the number of double bond. Okay, this one is 18O. 18O is 18 carbon, no double bond. Sebab dia 18 zero kan, ferric acid. Okay. And then 18-1. Okay, dia punya ni lari sikit. Okay, 18-1. So normally 1 ni satu double bond, location 1, 2, 3, 4, 5, 6, 7, 8, 9. So number 9 lah. Okay, number 9 from the carboxyl N. So dia akan 9. Okay, kalau kat sini 1, 2, 3, 4, 5, 6, 7, 8, 9 juga. Okay, because dia 18. And then 18-2. This one is linoleic acid, 18-2, so carbon. This one is a little bit move, but it's from here lah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 9, 12 lah, dia punya location dia. Okay. So 18-2 has 2 double bond, 18 carbon, and 9 and 12. The location of double bond. This one bersama. So normally dia 9, 12, 15. Linoleic acid. Okay. And then fatty acid also are named according to the location of the first double bond from the non-carboxyl N. Tadi kita tengok dia name daripada sini kan, yang omega tu. Kan, yang dia delta, 9, 12. Okay. Ada satu lagi cara where you can actually give the N system or omega tu. Okay, location of those is from the metal N. So kalau kita nak bagi nama macam ni, if you want to put this kind of name, we have to start from the metal N. So metal N, the metal carbon number 1, number 2, and number 3. So dia akan jadi omega 3. So this one will be or you can have it N3 lah, N-3. Okay, this one is using omega system. Macam banyak that we normally see this term in kat mana? Dalam telur kan. Kita kata beli telur omega. So this egg, normally they have omega 3, omega 6. Sometimes we use oil also, we have what type of omega kan. Macam the one that they use ingredient in in milk also they use this one. So what it means by omega is the location of the double bond if you start from the metal N. Jadi kita start dari sini. If you start from here, you will have a different nomenclature. You use the omega system lah. Okay. So this one will be omega 3, 3, 4, 5, omega 6, and omega 9. Itulah. Sama lah ni ya. Okay, omega 9, carbon number 9 from here, from this part, omega 6, carbon number 6 from the metal part, and omega 3, okay, 3, 6, 9. Alright. This is fatty acid synthesis. So animal can synthesize a fatty acid with a double bond in the omega 9 position, but not at the 3 and 6 position. So that means it has to be given. Animals, for example, ni dia boleh synthesize fatty acid. Kalau dia boleh synthesize fatty acid through dia punya biosynthesis pathway, but not on the 3 and omega 6 fatty acid. So this omega 3 and 6 fatty acid must come from the diet. So kena makan lah. Okay. So cold water fish accumulate high level of omega 3 fatty acid from their diet. So that's why source of the cold water fish, when you do the extraction to get from their muscle, you can get a lot of omega 3 fatty acid. Okay. This one is the omega system and essential fatty acid. Okay, linoleic acid is C18-2, is an omega-6 fatty acid. Linolenic is C18-3, and arachidonic acid is 24. These are all omega-3 fatty acid. Okay, so ini adalah arachidonic acid. Okay, so this is 24 and omega-6. So kita start daripada sinilah 1, 2, 3, 4, 5, 6. Okay, and then 24 is, this is location where, kalau dia start daripada sinilah. Okay, if you use the omega system, you have to write the one that is the first where the double bond is located from the methyl end. Okay, kalau kita nak tulis macam ni, okay, that is from the carboxylic end, the location. Okay, contoh. Okay, tadi we talk about melting points, right? So melting points, there are many factors that contribute to the melting points. One is the chain length. Okay, so the longer the chain length, the higher the melting point. So if you see here, 12, 14, 16, 18, and 20. So you have 44, 58, 63, 72, and 77. So from here, you can dictate. You can dictate which fatty acid are liquid at room temperature and which fatty acid are solid at room temperature. Tengok dia punya melting point tu. And room temperature normally kita pakai yang 28. Depends on where you are. Normally for Malaysia we use 28 lah for our room temperature. If you are in the temperate countries, like you are in the States, you will normally use about 22 degrees C. But now our room temperature is what, about 30, 32 kan? Sebab panas kan? Okay, the structure of some fatty acid normally found in drinking aids. Okay, this one is just examples lah. Okay, palmitic acid, stearic acid, palmitoleic acid, oleic acid. Okay, so these are the melting points. Okay, 16O, 18O, 16-1, 18-1. So you see that yang mana ada double bond, so your melting point is very low. So dalam room temperature dia adalah liquid lah. Okay, this one also liquid. Alright, palmitic acid and stearic, they are solid at room temperature. Okay, and then the other one is chain length. In most fats with a mixture of fatty acid, the chain length of the majority will determine the hardness. Hardness ni meaning that how easy for it to become liquid lah. Is a term for solid fat. Okay, nak tahu hardness. But for if we want to measure, you have to use instrument, the hardness, the texture analyzer. Texture analyzer can give you the hardness in terms of the reading using the analyzer. Okay, so if it's less than 10 carbons, it is liquid. Okay, if it is more than 20 carbon, it is solid. So between 10 or 20, they solid ke they liquid? Okay, which one? Alright, so you can see here, acetic acid, it is a vinegar, is liquid. Stearic acid with tallow, this solid. Arachidic acid, 20C, butter, so it is solid. So it actually depending on if you have this kind of chain length, okay, you have to see also how berapa dia punya, how many double bond does this fatty acid have. Okay, sini ya, melting points and double bond. Okay, so you have 18O, so you have the same fatty acid but a number of carbon, but you have different double bond then. One is 0, one is 1, another one is 2, another one is 3. So the more double bond, although they are the same number of carbon, if they are more double bond, that means they are more liquid in nature. So the liquid in nature, they have a lower melting point. Okay. So the one that is no double bond has a very high melting point. So you have to heat this palmitic acid, okay, uh, at high as 72, baru dia start to melt. Okay. So because of the presence of double bond, unsaturated fatty acid are more reactive chemically than saturated fatty acid. Kan dalam kimia kan, we're talking about how energy kan, molecule have their energy. Normally dia akan lebih stable bila dia tak reactive. Okay, so bila unsaturated fatty acid ni dia tend to be more reactive lah, because dia double bond, it is not as stable in terms of because it is always reactive. Kalau macam ada oxygen, dia akan react. Because of the double bond. So once dia dah jadi saturated, that is already saturated, dia dah tak boleh, they cannot, the structure, they cannot react with anything else anymore. So that means they already saturated lah, dia dah settle down. Okay, so because of the presence of this double bond, this unsaturated fatty acid, that's why they are more reactive than saturated. Okay, so this reactivity increase as the number of double bond increase. Of course, as we have one double bond versus 3 double bond, of course yang 3 tu lagi reactive because dia ada 3 tempat untuk dia react with oxygen, for example. Okay, although double bonds are normally occur in non-conjugated position, they can occur in conjugated position, alternating with single bond as illustrated below. Okay, ni maksud dia, kalau conjugated tu meaning that dia berselang. Berselang meaning that lepas double bond ada single bond, lepas double bond ada single bond. Okay, so that means you have 2, 1, 2, 1, 2, macam tu. Okay, that is called alternating with single bond. That is what we call conjugated. Okay, conjugated fatty acid. Okay, conjugated tu bukan maksud dia conjugate tu dia macam apa, something that conjugate dengan dia. Okay, but it means that it is alternate. Double bond is alternate with single bond. Okay. Because most of the fatty acid that we found kan, dia punya double bond location, normally tadi ada 3, 6, 9, 12, 15 kan. So lepas 3, 4, lepas tu 5 kan. So normally dia akan less than that lah, dia bukan conjugated macam ni kan. Mana tadi? Sini kan. So dia ada 3, 6 and 9. So 3, 4, 5. Kalau conjugated dia ada dekat sini. Macam tu kan. Okay, that means dia alternate. Mana tadi? Sebab tu dia cakap kat sini, although double bond normally occur in non-conjugated position. Selalu macam ni lah. Okay, 3, 4, 5, 6. So, lepas 3, carbon number 6. Dia tak macam ni. Okay, but they also can occur in this type of position. Okay. So you have to know the difference between conjugated and non-conjugated. Okay, and then we go to the isomer. Okay, isomer of this one is saturated. Nanti betulkan. Okay, isomer is a compound that have the same molecular formula and molecular weight, tapi dia punya structure is different. Okay, different. Two types of isomer among fatty acid. One is geometry, one is positional. Okay. Kalau geometry, satu cis, satu trans. Cis tadi macam mana kan? Kita dah tengok. Cis tu, that means they have the same position yang location dia tu. Okay. Cis or trans ni geometric isomer depending on configuration of the hydrogen atom attached to the carbon joined by the double bond. Normally dia memang dekat double bond lah. So cis isomer are those naturally occurring. Trans isomer occur due to partial hydrogenation of OPA. This one that I mentioned, dia akan tukar daripada cis ni kepada trans. Maksudnya daripada yang dua sama, the H or the R group is the same, and then they change it to one upper, one lower, or one satu depan, satu belakang lah if you see in 3D. Okay, because of the partial hydrogenation. Trans also occur in ruminant. Ruminant ni mostly animals lah, animals. Okay. Transconfiguration melts at higher temperature. That's the reason why companies, industry, dia tukar cis jadi trans, because if your fat, your product melts at lower temperature, nanti dia tak stable lah your shelf life kan. Your shelf life is not stable. And also cis are normally liquid state at room temperature. So if, like I said, if you want to make the spread, but using olive oil to make the spread, macam mana nak jadikan oil to partial solid kan? Okay, partial solid, that means dia bukan actual solid tapi dia more easy to be spread. Okay, so dia guna hydrogenation procedure. So change to from cis to trans, or letak hydrogen, dia tambah hydrogen. Okay. So elydic and oleic acid packing, melting or solidification, dia akan effect lah the packing, the melting and solidification. Okay. And then we have another isomerism, which is positional. Okay, this positional, the location of double bond differs among the isomer. Okay. So this petroselenic acid, which is present in some animal and vegetable fats, dia adalah 6-octadecanoic acid. That means the location double bond tu dekat 6, tapi dia 6. 6, that means both of the H group or R group is the same position. Okay. And they are positional isomer of oleic acid, 6,9-octadecanoic acid. So that means although they are different in terms of the location of the double bond, tapi dia punya isomer are the same, 6 and 6,9. Okay. The racemic acid, which is a minor acid in tallow and butterfat, is trans-11-octadecanoic acid, and both a positional and geometric isomer of oleic acid. Nanti kita tengok apa yang oleic acid and also the position and geometric isomer of the racemic acid. Dia sama macam ni lah. Okay. Semua dia cis and cis or trans and trans. Okay, dia sama macam tu. Okay, so cis-9-octadecanoic acid. So dekat sini cis-9 and then trans-11-octadecanoic acid. Dia akan jadi trans lah. So dengan cis-9-octadecanoic acid, which is another oleic acid. This one yang petroselenic acid ni is present. Is cis-6-octadecanoic acid and positional isomer of oleic acid. So positional isomer of cis-9, dia kata yang ini, position isomer dengan yang ini, sama dengan yang ini. Okay, cis-9-octadecanoic acid sama dengan kita panggil isomer secara positional. Okay, petroselenic acid, cis-6-octadecanoic acid. Okay. Okay, then we go to the physical properties of PAG depending primarily on the structure, interaction, and organization of the triacid glycerol. Okay, so the attraction, the strength of the attraction or attractive attraction between these two molecules and effectiveness of the packing within a condensed phase. Maksudnya macam mana dia packing within this phase of the solid or liquid is largely determine, dia akan determine dia punya thermal behavior. Thermal behavior ni nanti tengok dia nak melting kat mana, solid fat content dia macam mana. Okay, normally kalau thermal behavior kita ukur guna apa? DSC. DSC is scanning calorimetry. Okay, DSC density scanning calorimetry. So thermal behavior, nanti kita akan tengok macam mana how this fat will behave accordingly lah. Okay, dia also determine the density of the different fats and also the rheological properties of the fats. Okay, So physical properties of triacylglycerols, okay. Most liquid triacylglycerol are Newtonian liquids where viscosity is about 30 and 60 MPa, okay, millipascal per second at room temperature. Okay, so these are the rheological properties. The viscosity of liquid oil tends to decrease steadily, okay, with increasing temperature. So this one we call it in terms of rheological properties in terms of viscosity lah. Okay, can be described by a log relationship. The log relationship kalau satu naik, satu lagi akan naik lah. Okay. Okay, log relationship. So solid fat, they consist of mixture of fat crystal dispersed in a liquid oil matrix. So when we talk about fat, we also have to know about what type of crystal. Fat ni dia ada crystal structure. So if you take a fat and you put at a slide, okay, microscope slide, and then you see under microscope, actually dia nampak crystal. Okay, macam crystal structure. Okay. So solid fat ni normally it exhibit a type of rheological behavior is known as plasticity. Plasticity, plastic material behaves like a solid, okay, below a critical applied stress known as PO or yield stress, but behave like a liquid above this stress. So dia akan ada satu ni, I don't know if you can see this picture. It is quite small here. So this is the PO. Okay. So the higher, okay. So kalau bawah, lower than this PO, okay, P0 or we call it PO, it will behave like a liquid. But if it's higher than this PO, it will behave like a solid. Okay, so this is called plasticity of the solid fat lah. So important implication of the products, okay, because kalau macam manufacturers they want to do a product, they normally study this the rheological properties of the products. Okay, nanti whether which type of shear rate, I think you will learn this in one of your physical. I'm not sure if your course, do you have a physical characteristics of food? Do you study that? The physical analysis of physical characteristic of food? Ada tak belajar dalam you punya course? Because we don't cover this in our chemistry. Actually, we cover this in physical properties of food. Kalau in food tech student lah, I think you learn this also, right? For your physical characteristics of food. Okay. Okay, and then that one is rheological. Rheological is talking about the viscosity lah. Normally viscosity, so bila ada satu solid and liquid, then the viscosity will be different. Okay. Density is a repeat of the mass. We're talking about mass over volume lah. Okay, ketumpatan, mass over volume. So it is important when we want to design food processing operation. Okay, this one maybe relates to you kan. Even the rheological pun very related to your program, right? Okay, density. So bila kita nak design satu food process operation, so you have to know how much. Macam kita nak design satu bulk tank, that you have the volume, right? And then when you put the oil versus when you put water, of course the density is different. So they will act differently. So it determines the amount of material that can be stored in the tank or flow through a pipe and given volume. This is the one that is very important for you to understand. As an engineer, right? You have to take all this into account when you design a food processing operation. Okay, operations when you design an instrument for the food manufacturing. Okay. A certain food application because it influences the overall properties of the system. For example, creaming rate of all droplets in oil in water. This one very ni lah. So if you have a fat kan, kita ada ni, apa kita panggil macam yogurt,